Okay, so good morning. Welcome to our talk on plant adaptations to Mediterranean climates. So let's get started, and I will introduce our speaker for today. Dawn Kooyumjian is Program Coordinator for the Master Gardener Program of Alameda and Contra Costa counties, which are both part of the University of California Cooperative Extension Program. Additionally, she has taught plant identification and drought-tolerant garden design for the Department of Landscape Architecture at UC Berkeley. For many years, she was a staff horticulturist at the Blake Garden, the teaching and research garden for UC Berkeley's Landscape Architecture Department, where she tended, observed, and documented the plant collection. Her teaching and knowledge is firmly rooted in practical experience. She holds a Master of Landscape Architecture and is an International Society of Arboriculture certified arborist. So let's welcome Dawn. You have the stage.
Thank you, Connie. And welcome to our talk. We're going to start with a couple poll questions because that's, I think, always a fun way to start. And there are two in the first poll. One is, where did you grow up? Did you grow up in the Bay Area, the Central Valley, Southern California, somewhere else in the US, somewhere else in the world? And then I also am curious whether or not summer rain is common where you grew up. So the talk today is about plant adaptations to Mediterranean climate. And I'm going to talk a little bit about, first of all, what Mediterranean climate is, and then how plants are uniquely evolved and adapted to a really pretty unique climate. So we have another poll, but before we do that, let's look at the results of the first one. So what you can see, we have actually about half of the people are from California, either the Bay Area, Central Valley, and about half of the people on the call are from other places, either in the world or in other places in the US. And it's about almost, not quite 50-50 about summer rain, whether or not summer rain is common. We are in the climate with no summer rain. So we're going to talk a little bit about that. So for the next poll, which is about Mediterranean climate, and about what percentage of the world has a Mediterranean climate? Is it, it says 2, is it 10, is it 25, or is it 50%? So the correct answer is actually, it says 2, it should be 3%. 2% of the world. So it's actually a really uncommon climate. And I think we'll go from here onto the next slide. And it is, here's a map, because who doesn't like a good map? Here's a map of where we find Mediterranean climate in the world. And what you'll notice is it's in 2 equal bands, about equidistant from the equator. And you'll see California is pretty unusual. Of course, it's called Mediterranean because it's common around the Mediterranean Sea. And then in the Southern Hemisphere, there's a little bit of Chile, and then an itty-bitty part of South Africa on the Western Cape. And in Australia, the Western and South Australian part of the continent here. Not all of Australia is Mediterranean. And in fact, in the eastern part here, it's actually quite rainy. So when we're talking about plants that are Australian, they're not all necessarily adapted to a dry summer. So about Mediterranean climate is about 2% of the total land mass, as you saw in the map. And then this kind of shows you percentage-wise how it fills out. California has about 10% here. Now, to capitalize or not to capitalize, that is the question. So when you use Mediterranean as a proper noun for Mediterranean Sea, and it's capitalized, but when you use it as an adjective to modify climate, then it's not capitalized. So I point that out. Just if you see Mediterranean climate and it's not capitalized, it was not necessarily an oversight of the editor. It's just the accepted way to do it. So the characteristics of the Mediterranean climate, for those of you who are from California or live here now, especially in the Bay Area, you'll know that the winters tend to be short, mild, and rainy. We have summers that are long and hot, and they tend to be dry. And the other thing that's pretty interesting is that this climate usually happens on the west side of the continent, and usually moderated by a large body of water. So for us, it would be the Pacific Ocean. Around, of course, the Mediterranean Sea, it would be the Mediterranean Sea. So this kind of, again, shows you the place on the continent and the proximity to water. Now, this is kind of interesting. In California, Russ Beatty, who is a landscape architect and philosopher, used to be with the UC Berkeley Department of Landscape Architecture. He had this really interesting quote, which is, California is considered to be more Mediterranean than that of the Mediterranean basin itself. And what he means by that is that in most other parts of the world that have a Mediterranean climate, they get about 2/3 of their rainfall in the wintertime, which means at other times of the year, they get about 1/3 of their rain. Whereas in California, we get almost all of our rain in the wintertime. So that means that our dry season is correspondingly drier. And this is important to know as a gardener if you're thinking about how to select plants that will do well with our dry summers, is that plants that are from other parts of the world may need a little bit of supplemental irrigation in California during the summertime because our summers are much drier. Now, when you're thinking about rainfall, I think this is a pretty interesting chart. So it's not enough to think about how many inches of rain an area gets during the year. So you have to think about and understand how the rainfall pattern falls over the course of the year. So as an example, I've taken 3 cities that have about 24 inches of rain annually: Berkeley in California, Tierra Amarilla in New Mexico, and Merrifield, Minnesota. I'm not familiar with Merrifield, but this caught my eye for this example. So if you look at the California example, and you look at the charts here, what you'll see is we tend to get a little bit of rain in the fall, a lot of rain in the winter, a little bit in the spring, and hardly any in the summertime. But compare this to the New Mexico City, where it's pretty much evenly distributed over the course of the year. So even though we think of New Mexico as having more of a desert climate, of course, in the desert, they do get summer thunderstorms. So even though it's the same amount of water, how it's falling is different. And if we look at this example in Minnesota, they get almost no precipitation in the wintertime, which I imagine is because it's really, really cold, and they get all of their water and their rainfall in the summertime. So this is something to kind of put in your mind to think about for a little bit. Now, next, I want to talk a little bit about climate patterns in different kinds of climate. And this is a particularly, I think, a really brilliant graphic that was put together by Sean O'Hara with the Gardening in the World's Mediterranean Climate. And what he looked at was the blue here. He looked at rainfall, temperature, and the best growing season in both non-Mediterranean climates and Mediterranean climates throughout the world. And the blue, as you might expect, is rainfall, the yellow is temperature, and the green is what we might think of the prime growing season. So he looked all over the world. So in the non-Mediterranean climates, he looked at cities from Atlanta to Boston to Columbus, Ohio, Copenhagen, Delhi, London, Sydney, Paris, Ottawa. And what you can see is on the far left is the winter. It goes winter, spring, summer, autumn, and winter. And what you see in the non-Mediterranean climates is As we get into the spring, into the summer, the rainfall either goes up or it stays pretty constant through the summer. But of course, in the summertime, because it's summer, the temperature, in the winter it's cold and then it gets warm. And then, of course, it gets cool again. And then that equates to having a growing season that is really ideal from the spring until the fall, because of course you have the nice warm temperatures and you have a lot of water or adequate water. This is a very, very different pattern from what we see in the Mediterranean climate. So again, looking at cities all over the world, Adelaide, Athens, Greece, probably not Athens, Georgia, Barcelona, Cape Town, Santiago, San Francisco, you see a very, very different pattern. What you see, of course, is the temperature for the summer is the same, right? Because it's cooler in the winter and warms up in the summertime. But look at the rainfall. The rainfall, of course, in the Mediterranean climate is highest in the wintertime. And then as we get into the spring, into the summer, the rainfall really levels off. So what we have in our springs and summers in this kind of climate is the coupling of less water with a warmer temperature. And this is really, really different. And this is very, very obvious if you look at the hills, which of course, we're about here right now at the end of February. And if you think about how the non-irrigated landscape around us greens up, this is the pattern, right? We get those first fall rains, the hills start greening up. They're very, very green. The flowers start to bloom. And then as we get into the summer, things start to dry out. So we have another poll right now, and this is about droughts. So Connie, would you be able to launch that poll? So our droughts are rare occurrences in California. So is this true or false? And why don't we just go ahead and end the polling? And wow, this is really good. So most of you thought that droughts are not, this is a double negative. Droughts are not rare. Droughts are actually common in California. So let's move on to the next slide. And so I want to talk a little bit about California climate and the drought. And if you were around a few years ago, 2014, 15, 16, when we had a very severe drought, you heard a lot of the expression, brown is the new green, or this is the new normal. And what I want you to think about is that actually drought is normal, and perhaps it's not even new. So droughts are typical in California. And there's a little timeline here to show you. In 850 about, if you're familiar with Fallen Leaf Lake in Lake Tahoe, it had no water in it. And in 1580, it was so dry that the giant sequoias didn't register any growth in the Sierra Nevadas. Then about 1895, the California state weather records began. And we do have weather records. San Francisco has weather records going back to about 1850. But in general, the 20th century was an unusually wet century compared to the past. And this is important to understand because our water infrastructure was based on 20th century precipitation numbers. And I want to go back to this 1580 number. So if you are a California history buff, you may know that Sir Francis Drake landed in 1579. And he wrote that about how terrible the climate was in California, how awful. It was a horrible place that was dry and sere and just everything was dead. And it just, of course, coming from Europe, it was completely foreign. So of course, it is very different climate in California than it is in Europe, but it's also coupled with this idea that this was a drought period that happened in about 400 or 500 years ago. Now, here is a precipitation map. This goes from 1900 to about 2000. And what you can see here is this middle line is the average. And I think what I want you to notice is there is almost never an average year in California. It tends either to be very low, so these are drought years, or very high, so the El Nino years. Like if you remember the early 80s, we had some just drenching rains. So if you look at this 100-year period and you look at how many average years there are, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There may be 20 years. So it's, again, so we say that the average precipitation in the East Bay is about 24 inches, but that does not necessarily happen every year. It tends to be either very low or very high. Now, this is a really interesting graphic that was put together by Noah Diffenbach, who's a climatologist at Stanford. And this runs from 1900 to about 2014, because that's when this article came out, when we were in the key parts of that last drought cycle that we were in. And again, this black line or brown line, depending on how your monitor is the average. And the first thing is looking at precipitation, including rain and snow, which of course is what we just saw on the previous slide. And the brown dots or the black dots are the drought years. But what you can see with the next one is about the temperature. And what's happening is an overall trend of going up with the temperature. And then the third thing he looked at was something that's called the soil moisture index. And so this is how much water is available in the soil for the plants to get. And as you can imagine, it rains, and then the soil, if you're familiar with a little bit about soil, there are pore spaces in the soil that hold the water, hold air. And of course, as we get into the summer, that water level drops, so soil gets drier and drier. Well, we didn't have enough rainfall to replenish the soil reservoir. And what happened is sorry about that, coupled with the low soil moisture, increasing temperatures and lack of water, it got to be very, very stressful. And you probably have read about all of the tree dieback in the California forest and the bark beetles. Well, the trees were very stressed because there was just no more water for them to get because of the combination of temperature and drought. Another thing that when we think about water in California is that we really need to think about population. And I was kind of curious, this is population data off of the census, the 2010 census. We'll have new data pretty soon. And I was really curious about California. So right here, this is 1945. And of course, here's 1940. So you have people moving to California here, probably to work in the shipyards and the aerospace industry, and the population increases pretty steadily. And for comparison, I was just curious about a few other states, like Texas with the computers and the oil. Was curious how that compared. Florida as a place to retire. New York always has a lot of economic opportunity. North Carolina, thinking about like the NASCAR and the convention industry has really grown. And West Virginia and Wyoming, which you'll see the population has stayed static. So with our population growth, there's simply more people in California that we need to support with our finite water resources. Now, this is a really interesting website. This is called the Drought Monitor. It's from the University of Nebraska in Lincoln, and they track drought all over the United States. And I pulled a few maps off. So if you think back a couple of years ago, we had really nice rain in the wintertime. And we had a little bit of drought in the north, a little bit of drought in the desert. But for the most part, we were doing really well. Now, this map comes out every Thursday. So this is the one from this week. And the darker the color is, the more severe the drought is. So it is starting to move. And I just say this because we're going into another drought cycle. And I want people to really be thoughtful about what kinds of plant selections and what kinds of things you grow in the garden to really not be profligate with the water, but use it wisely. This map is also from the Drought Monitor, and this is looking about the California percentage of areas in drought since 2000. And again, you see these cycles of drought here at the beginning of the 2000s, 2007 to 2010. And then of course, this was the severe drought that we saw in 2014 to 2017. And we're getting ready, going kind of into another cycle. So it's a cycle, and we just need to be thoughtful about it and make wise choices in our gardens. So that's a little background about climate. And now I want to get to my favorite part, which is about plants, because I could talk about plants all day long. So I want to talk about plant adaptations to this climate. And so first, I just want a little reminder about why do plants even need water? They use water for a variety of purposes. Water, of course, is what holds the plants up. So when plants wilt, it's because their water is not getting up to the top of the plants. And then water is critical for photosynthesis. So you'll remember this from your science classes as a youth or maybe college, that plants take in carbon dioxide and water. They take the energy from the sun. And then I like to say magic happens in the leaf. And then we get sugar and oxygen. And these sugars, of course, are the building blocks for all of the carbohydrates and proteins and nutrients that basically feed us all. So I want to go back to this chart now. And so here we have the non-Mediterranean climates where I talked about, we have the, the warm or maybe hot temperatures, depending, this is Celsius, and coupled with some nice rainfall. So this is when things want to grow. But look at the Mediterranean climate. We have this warmer temperature coupled with low rainfall. And so my question for you to think about is, why doesn't everything just die here? Why doesn't everything just keel over? It's getting hot, there's no water. How do plants get through this extended warm period with little to no water? And that's this topic of my next section. So there are two main strategies. We have what are called drought resistors, and drought resistors kind of, they kind of hobble along during the drought, or more than hobble around. They're still present. And we also have what are called drought evaders. And these are things like bulbs and annuals that they're present in the spring and in the summer. And then when the weather is harsh, they just kind of vanish. And when the conditions are good, they came back. So they evade the drought. I like to say they take their ball and they go home until it's better for them to play again. So first I want to look at the drought resistors. So we have a lot of different leaf types that help with drought resistance. The first one I want to talk about is what we call sclerophyll leaves. So sclero is the Greek root for hard, and you'll know that from arterial sclerosis, hardening of the arteries, and phyll is the Greek word for leaf. So these are hard, leathery leaves that are resistant to dehydration. They're typically evergreen. They're sometimes a little bit waxy. And then the stomata, these are cells that are on the underside of the leaf, and this is under a microscope. So the stomata, the leaf of course goes this way, but I'm going to turn it this way. They are cells, and they open and they let the air and the water vapor go in and out of the leaf. And with these sclerophyll leaves, they have the ability to close up, so there's less water loss during the day. What that means, the plant, it will not be able to take in as much water, so it slows down its growth rate, it slows down the plant's ability to photosynthesize, but it does conserve water. So you'll be familiar with some of these trees, some of these examples. Here's some this is the coast live oak. This is a very common tree in the East Bay. And if you've ever picked up one of these leaves, you know that they are hard, they are leathery. They often have prickles to keep things from eating them, browsing on them, but they're very drought resistant. This is Quercus agrifolia. Here's a tree from Australia. This is the red flowering gum, Corymbia fusifolia. You may know it as red eucalyptus. And it too has a tough and leathery leaf. Now, eucalyptus, I know, is the plant everyone loves to hate, but they are really interesting. So these eucalyptus, this is the blue gum eucalyptus that's all over the place, Eucalyptus globulus. And what this plant does is that the leaves are aligned vertically. And if you think about this, this reduces the sun exposure, because if the leaf is going this way, the sun is going to come and really hit it. So if you think about in the old days before we knew about sun damage and skin, if you go to the beach to get a tan, right, you would lay down, you wouldn't stand up, because that maximizes your solar solar gain. So in these plants that have some drought resistant strategies, some of them have leaves that are vertically aligned, and that reduces the amount of surface that the plant is getting the sun, and that helps with dehydration. So we see this in eucalyptus, but we also see it, for example, in our native manzanitas. And you can see on this picture how the leaves are standing up and down. Now, another really interesting about eucalyptus is that the young leaves often are really, really different from the mature foliage. So this is my hand, which is not very big, and the leaves are almost as big as my hand. And what you'll notice is that they're large and they're flat. And yes, that's my dog making a cameo appearance. They're large and they're flat because think about this. These are leaves that are under a canopy, and they need to get the light, as much light as possible, so they can photosynthesize and grow and become a tree. And then at some point, there's a trigger that changes the shape of the leaf. So you can see these are the leaves from a prior year with the flatter leaves. And then this is the beginning of those narrower leaves that we associate with the eucalyptus. And this picture was taken in Wildcat Canyon. I'm noticing it's about 11:30, about halfway through our talk, and I just wanted to remind people, if you have questions, and as you have questions, go ahead and drop them into the chat box, and we will put them together and have a question and answer period at the end of the talk. So going back to the drought resistors and talking about foliage, another really common thing is to see gray leaves or hairy or fuzzy leaves. This is a coastal sagewort, and I think you can see how fuzzy the leaves are. And what this does is that in the morning or overnight, when there's just a little bit of water vapor in the air, it gets kind of trapped between those hairs, and that helps keep the water close to the plant. And then as the sun comes up and the water evaporates, that helps cool the leaf surface. So if you've ever wondered why you see a lot of drought tolerant plants that are gray, that is why. So we see this in our native Artemisia, but I put this in here because it's just kind of fun. This is a plant that's not gray. You can still see the green underneath it. It's a Plectranthus, and you can see it. It's very, very fuzzy, but it still has the green leaf to it. Now, ferns. We think about, you close your eyes and think about a fern. Think about being in a nice green and verdant forest, and maybe you come across a grotto with some rocks and some dripping water, and it's full of ferns, and maybe there's even a little nymph there. Ferns are actually a kind of plant, and we find a lot of ferns in damper climates, but we also have ferns that are native to the desert. And this is a lip fern. It's called Chelanthus. These you can occasionally find in your local nursery. And what I want you to notice is that the ferns are a little bit fuzzy. So it's a similar strategy. Now, what I will say about these drought-resistant ferns, they tend to grow really very close to rocks. And so their roots go under the rocks. And of course, the rocks serve as a mulch. And so that's going to be a damper place in the area. But they are native to the desert. If you go to the University of California Botanic Garden, there's some of these growing in the cactus garden. And there's also a whole display of them near the entrance. They're pretty interesting. They're called xerophytic ferns. And then for some extra drama, we have this purple Berklia, which looks like it is completely covered with cobwebs. And so you can imagine how the water would get trapped in here. And I'm really excited. I just ordered seeds for this. I'm going to try to grow this. This was taken up at the UC Botanic Garden. So thinking again about color, if in hot weather, I think unless you are a teenager, dry, light colored clothes are going to help reflect the heat and keep you cooler. And it's the same thing with these white leaves and these white colored plants. The gray or the gray-green light helps to reflect the sunlight and keep the plants cool so they don't absorb like a dark leaf will absorb, or the asphalt, is dark and it absorbs and gets hot, the light color reflects the heat. So this is velvet centuria. We also see this, for example, with this Dichondra, and this is an echeveria, and I just wanted to show that even though we have similar colors in terms of grays and gray greens and a little bit of purple even, you can do really interesting combinations with form and texture. Another strategy for drought resistance is what's called being glaucous. And glaucous is a waxy coating that tends to have a blue-green cast, and that waxy coating helps reduce the water loss to evaporation. So this is a plant called Dianella, baby bliss, and it does get little tiny blue flowers on it, but it's really grown more for its color and structure. Succulents. Succulents are very, very popular right now, and a really interesting group of plants. Being able to, if you look at this, is the giant chalk dudley. This is a California native plant. And what you're seeing here and here and here are fingerprints. These plants have what is called bloom or farinose, like farina, meaning the kind of flour that you make biscuits out of. It have a powdery coating on them. And that powdery coating, of course, makes the plant very light in color, and that will reflect the sunlight. However, the plant is unable to regenerate this powder. So if you yourself, or if you have friends that are succulent fanatics, they get very upset if you touch their plants, because it's unsightly, of course, because it takes away the beauty of this white color, but it also damages the plant because this area is now subject to sunburn. So this farinose powder acts kind of like sunscreen for the plant. Doesn't have to be white, it can be purple. I just put this in here because it's just kind of fun. So here is an example of the powder on a purple plant. The red color is also something we see as a adaptation to reduce from places that are very, very sunny. Foliage, another strategy is to have teeny tiny leaves. So this is a California lilac, Vandenberg. It was found at the Vandenberg Air Force Base down in Southern California. And I happened to have a dime with me that day, and you can see how itty bitty the leaves are. So when you have smaller leaves, you have less surface area to lose the water. So here's an example of a native plant. Here is, I think this is a really quite lovely shrub that is from Australia. It's called Baki regatta. And again, it has almost needle-like leaves, and they're green. So for people that are maybe not so crazy about the gray look, there are plants that are tolerate dry summers that do have green leaves. Now here's another cool thing that the plants do. Something that's called seasonal dimorphism. So di, of course, means two, and morph means shape. So these are plants that have leaves that go in two shapes. So what happens, it happens with this, you may know Jerusalem sage, and this is the California purple sage. In the spring, the plant is just coming out of the winter. It's been cold. It hasn't really been growing. And then as the temperature starts to warm up, there's still water, and the plant wants to grow, make big leaves so it can catch as much sunlight, make as much food for itself, and grow as fast as possible. And then as you get more into the summer, the plant slows down and it gets smaller and smaller leaves. And that, again, is sort of following the trajectory of warmth and water to grow bigger and faster. And then as it gets hotter and less water, the plant starts to really conserve its resources. Plants also have the ability to store their water in their stems. This plant is from Southern California. It's giant coreopsis, and it is indeed giant. You don't really have a way for the scale here, but it can be 5 or 6 feet tall, and it's able to store its water in its stem. And it does have little yellow daisy flowers, but by the end of the summer, all of the leaves fall off, and you have this kind of Dr. Seuss sort of fantastical looking plant that is just standing by until it starts to rain again. So not only can soft-stemmed, soft plants store water, but also things like the bottle tree, where plants can store their water in their trunks. Plants can also store their water in their leaves. Sometimes, people call this a black rose. This actually is not a flower structure. This is a rosette of leaves, and the leaves are able to store the water. So store water in stems, store water in leaves. Another place to store water is in stems in cactus. So the spines on a cactus are actually what used to be the leaves, and over millennia, the leaves have gotten smaller and smaller and smaller, so they don't lose water. And then the stems have gotten the chlorophyll, so that the stems are what are actually photosynthesizing, so storing the water in stems. So now we have another poll, which is kind of check your knowledge. And so drought resistant strategies include, and you can check 1 or 2 or 3. Do drought resistant strategies include tough leathery evergreen leaves, gray fuzzy leaves, tiny leaves? And I think just to, we'll end the poll just to keep things moving along. And they actually, all 3 are strategies for resisting drought. So next I want to talk about the drought evaders. And so as I said earlier, these are the plants I like to think of. They're just going to take their ball and go home and not play the game until conditions are right. So for those of you, and I believe it was about half of the people in this for this talk who did not grow up in California, we have something that is very, very strange. We have what is called plants that are drought deciduous or summer deciduous. So this is a Aesculus californica. This is the California buckeye. If you're out for a walk in the hills, these are starting to leaf out now. They're beautiful green plant with beautiful, very showy and fragrant spikes of flowers. But by the time you get to the summer, what happens is the plant drops its leaves. And if you grew up with summer rain, this is really strange to see a plant that it looks like it's dead, but it's, if you know the Monty Python skit about the parrots, this tree is actually not dead, it's only sleeping, which of course is what the word dormant comes from. The tree is asleep. If you think about deciduousness in the plants that drop their leaves in a colder climate, think about when the environmental stress is. If you're a sugar maple in Vermont, the time that's hard to get through in terms of the environment is the winter time, because it is so cold and because of the freezing weather. So the plants drop their leaves to sort of slow themselves down, make it through the winter, and then leaf out in the spring. But in the Mediterranean climate, the time of most stress is in the summertime, with that, again, the warmer temperatures coupled with the less and less available water in the soil. So we also have what are called geophytes, or we can just call them bulbs. Bulbs have a very specific definition in botany, but we'll just use it in general. And bulbs are a way that plants can store water underground in their roots. So we earlier talked about storing water in leaves and in stems, but plants can also store the water in their roots. And if you think about bulbs, they think about this. They often bloom in the spring and the summer, right? Think about summer, the daffodils. I'm starting to see daffodils in the stores now. They grow, they bloom, and then they go away. The bulb is able to store food underground. And of course, underground, it's insulated, so the temperature is not as variable. And they have a very unique strategy. Bulbs can often reproduce by offsets. They make little bulbs around the bottom. So if they're not able to grow, or the plants can't bloom because the environment conditions are not right that year, they still can manage to multiply. And bulbs can stay dormant for years until the conditions are conducive to growth. And when I used to work at at Blake Garden, we had a plant, a California native plant you may know that's called California shooting stars. And that plant would disappear for years. And then every 4 or 5 years, the conditions would be right. And it would come up and it would bloom and we'd all go down and look at it because it only blooms for a couple of weeks. But you just don't know if they're dead or not because they're all underground. And then one year you have a really nice surprise. So of course, I wanted to use the example of tulips as a bulb. And I think we can now do the next poll, which I'm going to go back a slide. Tulips are native to Holland and Northern Europe, the African savanna, the Andes, or the mountains of Central Asia. And let's end the polling and share the results. And it was equally divided between Holland and the mountains of Central Asia. And the answer to this is tulips are actually native to the mountains of Central Asia. They're from Afghanistan, they're from high mountains, very rocky soils, poor soils, and extreme temperature, cold and heat. However, the Dutch were great commodity traders, and they saw a commodity and really took those tulips, hybridized them, and that's why we often associate Holland with tulips, but they're not actually native to Holland. They're native to the mountains of Central Asia. And there are bulbs that are from Africa and from the Andes as well in California. So California actually has a lot of native bulbs in its flora. This is Calochortus, the Mariposa lily. And if you look closely, we have a little spotted cucumber beetle here. They have beautiful, beautiful markings. Ethereal spear, Brodia, these are all California native bulbs. The California native bulbs tend to want really good drainage and are not very adaptable to soil and water conditions. So they're not as commonly grown as some of the other bulbs for other parts of the world, but know that we have a lot of beautiful native California bulbs. We also have annuals. So these are, a true annual is a plant that the seed drops into the ground, it germinates, it grows, it blooms, it makes seeds, and then it dies all in 1 year. And no matter what you do, you cannot make that plant grow longer than 1 year. Now, a lot of plants that are considered annuals in your gardening books, which usually are written by people from the East Coast, in California or in their native climate are actually perennial. So I'll use the example of Sweet Alyssum. Sweet Alyssum is often considered an annual, but it's actually a woody subshrub. If you've ever had Sweet Alyssum in your garden that's lived for a couple of years, you'll notice that it's a little bit woody under there. So an annual is something like basil. Probably many of you have grown basil, and then you'll read or you'll be told, keep cutting the flowers off and it'll keep growing. But eventually, no matter how fast you cut those flowers off, the plant dies. That's an example of an annual. And so what this does is the plant, again, it's taking advantage of the environmental conditions of warmth and water. They grow, they bloom. The seeds then just wait in the soil until the conditions are right the next year to grow. So we have tons of beautiful annuals in California. This is Globigilia, Gilia capitata. And just sort of fun fact here is Gilia capitata has blue pollen. And if you look at the little bee here, you can see it has blue pollen in its little pollen baskets here. Another spectacular California native plant combination of annuals, again, baby blue eyes and tidy tips. So kind of to summarize, plant strategies for surviving drought. Those drought resistors, they have a certain look to them. They're either dark green and leathery. They're often, you'll see fuzzy leaves, blue or gray foliage, tiny leaves, or things that have water storage in their leaves and stems. So like succulents and things that have a lot of presence. So when you're designing with drought tolerant plants, if you use too much of any of these things, everything kind of blurs together. So it's really good to think about the different textures and colors. And then with drought evaders, people think we don't have seasons in California, but we do. Our seasons are just a little bit different. So with the drought evaders, they are either absent or dormant for part of the year, and then they come up and you have these really lovely surprises. So think about including these in your garden. Most landscaping big landscaping companies don't do these because they're seasonally available, and there's a whole kind of cycle about when that happens. But as a home gardener, really encourage you to think about seasonal color with these drought evaders. And I have just a few more things I want to share with you, is to talk a little bit about seasonality. So people think of seasons as being the 4 seasons of the Northeast or of the North, right? Where you have a snowy winter, you have a beautiful floriferous spring, rainy summer, beautiful fall color. But what I want you to think about is we have seasons too. And our seasons are a little bit different. We have the rainy season, the green season, the late winter into the spring, and followed by the dry season. And what I want you to start, really thinking about is that this is actually quite beautiful. And we really have to, start accepting that this is okay. This is part of what we live. We have this for part of the year and we should really enjoy it while it happens, but this is absolutely fine. And I want to go back to this slide. So here is the snowy winter and here's the spring, and you can see that the trees in the back even haven't leafed out. So if you go to here, we look at this and we think, wow, if we just add water, we can have this year round, which has kind of been our approach to California, because we really can grow just about everything here if we add water. Nobody looks at this and says, wow, if we just add heat, we could have this all year. Because of course, when you add heat to this, you get a greenhouse. So it really is becoming understanding our climate and being comfortable with it. Our ideas about garden design and appropriate plants were really informed by gardening in Northern Europe that came to the Eastern US, that things are just different here, and we can do things here that you can't do. So to close, I wanted just to end with some pretty pictures of some plantings that I think are really attractive, that don't need a lot of water. So, and I'm just going to point out some of the design things here. So look at this. We have little light green leaves that are kind of round, contrasted with these slightly darker leaves that are more linear, and some little purple flowers. And that, I think, is a very, very pleasing and restful combination. And look, it's green. Here's another one, combining kind of a larger leaf. This is hummingbird sage. This, I believe, is a verbena or an oregano. This is California buckwheat. And you see the spikes of red, the kind of purple haze, and it's just kind of a very appealing combination. This is at the San Francisco Botanic Garden. And again, you'll see an interesting vertical white element with the palm, the orange, the burst, kind of a starburst from the yucca with this spike of white flowers, the accent of the purple. And again, these are all low water plants. This is Beshanaria with these beautiful pink stems. Here's another one from the Arboretum in San Francisco, Agapanthus. We tend to think it's overused, which it is, but there's nothing that has flowers as big as your head that is this color. And the purple and the light color, all low water plants. Succulents. You can do all kinds of interesting things with color. You see kind of a smaller one here, a bigger one, a longer shape. And again, not a lot of water, but a lot of visual interest. So that is how I'd like to close my talk. And I think next we'll take a few minutes for questions.
So far we have only one question, and that is, what does the SP period mean? You had the Calochortus SP.
Aha. So SP period means species. So there are many, so Calochortus is the genus, and there are many, many kinds of Calochortus. And so when you use the SP period, it means you're talking about all of them, all of the different species kind of as a group rather than one individual.
That's the only question
No,
I have.
actually, Veronica, some people sent questions privately to me. This is Joan. So there's just a couple more.
Go
One
ahead.
is a comment, and it had to do with the poll on strategies. And people only were allowed to choose one. I think the poll was ambiguous because all of the strategies were correct.
Oh,
you
okay.
said that, Dawn. Yeah.
Right. Okay. So we thank you for saying that.
So the poll was ambiguous.
Yeah. So we can thank you for pointing that out. We'll fix that for the next time we give this talk.
And there's another question about somebody asking for any lists for email suggestions to specific trees or plants that are city-based.
City-based. I believe, that would be a good question to send to the help desk, which is here. Now there's a really great tree website that's called Select Tree, all one word. It comes from Cal Poly and San Luis Obispo. And it is a website where you can select your climate. You can put in your sunset zone. So in Alameda County, I believe we have 15, 16, 17. You can put your climate zone. You can put how large a tree you want. Do you want a small tree, say under 25 feet, or do you want a larger tree? Do you want a deciduous tree or an evergreen tree? And you can check these different boxes, and then it will return a list of trees that meet those criteria.
Joan, did you finish? I have a question here.
Oh, yes, Veronica, thank you.
Are there any suggestions for screening plants for a fence line that is under a coast live oak that grow tall and have low water needs?
So what I would do for that is when you have coast live oaks, as you know, those are plants that are very adapted to the dry summers. And when you plant near a coast live oak, you need to make sure that the plants that go under it are of similar water needs, meaning something that can get through the summer without any water or very, very little water. And the thing to remember with trees, we have the I'm going to kind of go back here. You have the canopy and the trunk, or oaks tend to be very wide. The coast live oaks have a wide canopy and the trunk, but you need to remember that the roots actually go out beyond the area of the canopy. So just because you're not underneath the canopy doesn't mean that you can start watering more. So what I would suggest for you is if you go to the California Native Plant Society, there's a website that's called Calscape, and I believe this is in our resource list, which we're going to drop into the chat box. And you can put in some criteria for shrubs and for water use. And there are also, for example, in the Sunset Western Garden book and in the East Bay Plants for Summer Dry Climates book, there are some lists of plants that you can plant with the California native oaks that you might find of use. If there are no more questions, I'll just maybe close with thanking everybody for coming. And just wanted to remind you that we have year-round information on our website, all kinds of stuff. We have videos and a lot about growing your own food, which of course is a very hot topic right now, a little bit about what our Master Gardener program does, outstanding plants for Alameda County. We have all kinds of social media. If you are into social media and you'd like to follow us on Twitter, Facebook, Instagram, or YouTube. I mentioned our help desk. We have a help desk staffed by trained Master Gardener volunteers who will research your gardening question and get back to you with an answer. And there is a link on our website for a form for questions, or you can just simply email them at this address. We also have 5 demonstration gardens throughout the county, and I'd like to point out this picture is from Quarry Lakes, which is in Fremont. It's a garden that focuses on drought tolerant and climate adapted plants, and also our garden in Livermore, where we all know it's very hot in the summertime. A really lovely garden that showcases plants that are adapted to the hot, dry summers. And then the Lake Merritt Albany and Hayward demonstration gardens are all focused on growing food in your food garden. We also have speaking engagements, help desk in our website. And I think that is everything I have. So thank you so much.